Welcome to the engineer mechanics course. Today we'll start our another chapter of engineer mechanics, which is friction. So friction, as all we know, friction is an agent which retards the motion of a body. So in every day-to-day our life activities, we experience frictions. While from starting from our running activities or walking activities, there is definitely some type of friction is occurring between our foot and the road. So the more our forces, the less will be the frictional forces, because friction force will be maximum up to a certain limit. Once the applied force crosses the limit, the frictional effect will not come into much effect. So the applying force, when the applying force is more than the frictional force, the body will be in motion, or it will move. So friction is defined as that force which opposes or retards the motion of another objects when sliding over another. There are mainly different four types of friction: static friction, sliding friction, rolling friction, and fluid friction. So friction and normal force, these two forces are perpendicular to each other. The normal force is means when a body is resting or giving some reaction to another body, that body will provide another force which is called the normal force. So when the speed is increasing, the sliding friction reduces, but whereas the fluid friction increases with the increase in the relative speed. Because why? Because there that one, their viscosity of the fluid, due to the viscosity of fluid and due to the surface interaction of the fluid, this frictional fluid friction increases. So consider this figure. There are one rotating ball or object. You see here this one. Here the body, the first figure, it you see the body will be in the translatory motion, FL. So the body will be only the sliding motion. But if you consider in this figure B at that point, so there are the body will be in the translatory as well as the rotational motion. So when the body rotates, this is called the rotational, and when the body only slides, this is called the translation motion. So when if we consider the rotational motion, point B will move backwards if the VR is greater than VL. So if we consider only the linear motion, VL will move in the forward direction. So the resultant motion B will be the superposition of this VL and VR. If VL is greater than VR, the body will move this direction, and VR is, if VR will be more, the body will be traveling in the opposite direction. So if VR is greater than VL, the body B will move in the backward direction, because as we know, the friction force opposes the motion between the surfaces, hence it will act in the forward direction. But when VR is less than VL, that means the body will move in the forward direction. At this point, the friction force acts in the backward directions. But if VL is equal to VR, that means the body, although the body will be moving in the forward direction, but the frictional force is zero. This is unlike when we experience this one, when a body is moving in direction where their frictional force is zero. This condition is like that, although VL equal to VR. So this figure, it will show that here this one static friction is static friction, as all you know, the static friction acts when the body is at rest. So that means there is no motion due to the action of the static friction. There will be no movement that the body is red. This is the sliding friction. So when the body in the sliding motion, this is the sliding friction. So this will provide the sliding motion. And this is rolling motion. This is due to the rolling friction. So this body, the rolling motion will be acting this in this direction. The rolling friction will act direction to retard this motion. So now we'll discuss what is actually static friction. So static friction, it is at the frictional force that occurs between the body when they are rest with one another. So magnitude of a static friction or static force is equal and in opposite direction when a small force is applied. But when the frictional force reaches at some point, then when the forces exert at friction forces at some point, that is called a maximum frictional forces. So example of static frictional: skiing against the snow, then rubbing hand by creating heat together, then table lamp resting on the table. These are some example of the static friction. Then coefficient of the static friction, how we can define the coefficient of the static friction? The maximum force of static friction, it is the product of the coefficient of static friction and normal force, and force of the static friction is less than or equal to the product of the coefficient of static friction and normal force. So it is given by the formula Fs maximum. There's a maximum static friction. It is given by the product of the coefficient of static friction and a normal force. Here eta is the normal force here, but Fs is always either may be less than or equal to the this one, because this is the condition for the static friction. Then sliding friction, it can be defined, which is the opposition, that means the resistance it is experiences when a body slides against one another. So example are like that: two carts sliding against each other in a deck, then sliding of the block across the floor, then skidding. These are some sliding friction. Then likewise the static friction, the coefficient of sliding friction, it is also denoted by mu s. Then force of the sliding friction, it is defined by the product of the coefficient of sliding friction and the normal force. So Fs equal to, that is also coefficient of sliding force equal to Fs equal to mu s into Fn, where mu s is the coefficient of sliding, Fn is the normal force. Then rolling friction, what is rolling friction? Rolling friction, it can be defined with as the force which resists the motion of the body when a ball or wheel is moving around it, and it is the weakest type of the friction among all the frictions, like wheels of the moving vehicles. These are some examples of the rolling friction. Then coefficient of the rolling friction, it is defined by mu r. It is also defined as the product of the coefficient of the rolling friction and the normal force, Fs equal to mu r into Fn. So these are the three: static friction, then sliding friction, and these are rolling friction. Then fluid friction, generally it occurs on fluid. So it is the type of friction which generally occurs between different layers of the fluid when they are moving relative to one another.